The last video in the chemical basics unit is on chemical nomenclature. The word nomenclature simply means the rules for naming things. So we're looking at how we name chemical compounds. Here are the learning targets for this video, and you can see they all center around naming compounds and writing the formulas for compounds. First of which, we want to be able to name ionic compounds using what is called the stock system nomenclature rules. The stock system was simply developed by a scientist by the name of Stock, so that's what's called the stock system. So the stock system deals with ionic compounds. Here are some basic rules for the stock system. The simple rule, and really it's the only rule there is that we simply name an ionic compound by naming the cation followed by the anion. So cation first, then we follow that with the anion name. Now the next question is obviously, how do I name the cations and the anions? Well, this is something that you've been doing already in class. For monatomic cations, and recall monatomic means one atom in the ion, and cations means it's positively charged, we have two situations. If the monatomic cation is from group 1, group 2, aluminum, zinc, or silver, we just give the name of the metal only. That's all we need to do, because simply giving the name of the metal tells us the charge. For example, we know any group 2 element would be 2+. We know aluminum is always 3+. We know silver is always 1+, etc. If it's any other metal, we must give the name, but then we also must indicate the charge after the name with a Roman numeral, and then we put that in parentheses. And we've seen some of this already in class and some of the labs that we've done. We'll formalize that learning here a little more in this video. If it's a monatomic anion, then we drop the ending of the element name and we put the IDE ending on it. So recall, anions are negatively charged. So this would be like the oxide ion or the fluoride ion. And the other possibility is if we have a polyatomic ion. And there we simply just give the name of the ion. And recall, you have a polyatomic ion chart that you can look at, and you can get those names from that chart. So let's look at some examples. We just want to name each compound. So the first one we have here is Al2O3. So look at the ions in it. Look at the cation and the anion. Okay, notice here we have aluminum and we have oxide. And ask yourself, for the aluminum, do we need to indicate the charge on the aluminum? And the answer is no, because aluminum is always 3+. And the name of the anion is oxide, so the name of this compound is simply aluminum oxide. Alright, next example. AgNO3. Again, look at your ions. Our cation here is a silver ion, Ag, and then our anion is a polyatomic ion, NO3. So silver, again, ask yourself, do we need to indicate its charge? The answer is no, we don't. It's always 1+. And then look up the polyatomic ion NO3 on your polyatomic ion chart, and you'll see that that is the nitrate ion. So the name of this compound is simply silver nitrate. Next, we have MgOH2. Again, look at your anions. Our cation is magnesium. Ask yourself, do we need to indicate the charge on the magnesium ion? The answer to that is no, because magnesium is in group 2, so it's always 2+. And then OH is a polyatomic ion. Look at your polyatomic ion chart. Look up that name, and you'll see that it is the hydroxide ion. And so the name for this compound would be magnesium hydroxide. Next, we have CuCl. Looking at our cation here, we have copper. Our anion is a chloride ion. Ask yourself, do we need to indicate the charge on the copper ion? And the answer here is yes, we do, because copper is not in group 1, it's not in group 2, nor is it aluminum, zinc, or silver. So the name of this compound is going to be copper, and then we need to indicate the charge in Roman numerals, and I'm putting a question mark there for now, and then chloride. The question becomes how do we know what the charge is on the copper ion, because it's not in group 1 or 2, and it's not one of those that always has the same charge. Well, you have to look at the anion. We know that the total charge in the compound will always be neutral. We know that the charge is always balanced. So looking at the anion, looking at the chloride, we know that the charge on a chloride ion is 1-. Okay, it's always 1- because it's in group 17. You'll gain 1 electron to have that 1- charge. So ask yourself, what does the charge on the copper ion have to be in order to balance out that chloride ion? Well, the answer here, it has to be 1+. Because notice there's one chloride ion, there's also just one copper ion. So the copper has to be 1 plus to balance with the chloride. So the name of this compound is copper 1 chloride, where the Roman numeral 1 goes in parentheses next to the copper to indicate its charge. So copper 1 chloride. Alright, next example. FeSO4. Once again, ask yourself what ions we have. We have an iron ion, and then we have a sulfate, that's a polyatomic ion. Let's look that up on your periodic, not your periodic table, your polyatomic ion chart. And once again, ask yourself, do we need to indicate the charge on the iron? And the answer is yes, we do. Because iron is not in group 1, it's not in group 2, nor is it aluminum, zinc, or silver. So we do need to indicate the charge. So the name of this compound will be iron something sulfate, where that something is the charge on the iron ion. So again, to determine that charge, we need to look at the anion. So look at your polyatomic ion chart and look at the formula for the sulfate ion. You will see that it is a 2 minus charge. 2 minus charge. So now ask yourself, what does the charge on the iron have to be in order to balance or cancel with the 2 minus of the sulfate? And again, look at your formula here and see that there's one of each ion. We have one iron ion, we have one sulfate ion. Remember, this whole thing, SO4, is one ion. It's not 4 of them, it's just one. So because of that, the charge on the iron has to be 2 plus to cancel with the 2 minus, because there's simply one of each. So the name of this compound is iron 2 sulfate. And it looks like I forgot to enter that here. So this over here should say iron 2 sulfate with the Roman numeral 2 there for the question mark. Alright, next one. We have SnO2. So looking at our ions here, we have Sn, which is tin, and then we have O2, or an O, which would be the oxide ion. So this is going to be tin oxide, but again, ask yourself, what does, or do we need to indicate the charge on the tin? And the answer is yes, we do. Oh, there it was. There's the iron 2 sulfate. I just put them out of order. Alright, so this compound here on F is going to be named tin something oxide. So I need to look at the charge on the anion. I know that an oxide ion is 2 minus. I know that it's 2 minus because it's in group 16, so it'll gain 2 electrons. Now in this case, the charge on the tin will not be 2 plus, and the reason is I don't have the same number of ions of each. Notice I have one tin ion, but I have 2 oxide ions. So if I have 2 oxide ions, the total negative charge then is 4 minus. Because I have an O2 minus, I have another O2 minus. So that would mean it's a total of 4 minus. So my charge on my tin ion then has to be 4 plus. Okay, so the name of this compound is tin 4. Notice the Roman numeral 4 there, oxide. Alright, we've completed our first learning target here for this video. We have named ionic compounds using the stock system nomenclature rules. The next thing we want to do is we just want to go the other way. We want to write the formulas of these ionic compounds. So let's look at some examples of that. So we're simply told to write the formula for each compound. First one we have here is chromium 3 iodide. Now recall for these ionic compounds that the charges on the ions are always going to balance. They're going to add up to 0, or they're going to cancel. So the first thing I would do is I would make sure I know what the charge is on each of those ions. So I'm going to write the formulas of the ions here down here below the name of the compound, and then we'll write the formula for the compound out here to the right. So chromium 3, remember this Roman numeral 3 here, that tells you the charge. It does not mean that there are 3 chromium ions. There could be, that is a possibility, but that's not what it means. It means that the charge on the ion is 3 plus. So it's chromium 3 plus. Iodide, that comes from the element iodine. Iodine is in the 17th group, so it'll gain 1 electron. So its charge will be 1 minus. So the formula here, notice if I have one of each of these ions, the charges will not balance because I have a 3 plus, I have a 1 minus. So I would need 3 iodide ions to cancel or balance with the chromium's 3 plus. So the formula here is Cri3. Next one. We have barium nitrite. So again, I want to identify the charges on the ions. Barium is in group number 2, so that's going to be 2 plus. And then notice the nitrite, ITE ending. Remember that tells you it's a polyatomic ion. So for that, go to your polyatomic ion chart, find the nitrite ion, and you will see that its formula is NO2 and it has a 1 minus charge. And now you want to ask yourself, how many of each ion do we need so that the charges cancel? Well, the barium is 2 plus, and the nitrite is 1 minus. Remember, this whole thing is one ion. It has a 1 minus charge. So I need 2 nitrite ions to balance with the charge on the barium. So the formula for this would be BaNO2, 2. And then notice the parentheses around the NO2, because remember that whole thing again is one ion, and I can never change the formula of that. If that's a nitrite ion, the formula is NO2. So I can't change that if it's nitrite, because then it wouldn't be nitrite. So BaNO2, 2. Next example, we have osmium 6 chromate. So the Roman numeral here, Vi, that is 6. And remember again that Roman numeral tells us the charge on the ion. So this would be osmium 6 plus, OS 6 plus. And then chromate, notice the ATE ending. There's another example of a polyatomic ion. So look at your polyatomic ion chart, and you'll see that its formula is CrO4 and has a 2 minus charge. Now ask yourself, how many of each ion do we need so that the charges cancel or balance? And if I have a 6 plus charge for the osmium, I would need 3 chromate ions, each which are 2 minus, to equal a total of 6 minus. So just think about that. 2 minus, and another 2 minus, and another 2 minus. So it would be 2 minus times 3. That would be 6 minus. That would cancel with the 6 plus. So I need 3 chromate ions for each osmium 6 ion. So my formula would be OS CrO4 3. Where I have 3 chromate ions, you can see there with the parentheses around the chromate formula. Last example, we have lithium bromide. So lithium is in group number 1, so that's always 1 plus. The bromide ion, that's the monatomic anion of bromine. Bromine is in group number 17, so that will be 1 minus. It will gain 1 valence electron. So I have 1 plus and 1 minus. The charges cancel if I have one of each, so the formula here is simply LiBr. Alright, that completes the second learning target here. We have both named ionic compounds and we have written formulas for ionic compounds. The next thing we want to do is we want to look at binary nonmetal compounds, or another way to put that would be simple covalent compounds. Now, we really haven't learned much about covalent bonding yet, and up to this point it's really not important for us to know too much about the bonding, but it is nice to be able to name the compounds when we see them. So the term binary, let's think about that here for a second. Let me click over here. The term binary, that just means it's made of 2 elements. Okay, bi, the prefix bi meaning 2, and so that means that these compounds here, they're both nonmetals. Okay, because we have binary nonmetal compounds, so both elements are nonmetals, and there are 2 nonmetals in it. How binary nonmetal nomenclature works is we need to use prefixes to indicate the number of atoms of each element. Now think about how this differs from the ionic nomenclature that we just learned. With that nomenclature, we don't indicate the number of ions because we can determine that based on the charges of the ions. We can figure out how many of each we need to cancel. With these covalent or the binary nonmetal compounds, there are no ions, there are no charges, so there's nothing to cancel. So the name has to tell us how many atoms to use in order for us to write the formula correctly, because if not, we'd have no indication of that. So the prefixes here, and I'll just quickly click through these. I would recommend pausing the video at the end of them. We'll go up to 10, and then just take a moment and work on remembering them. You will need to memorize these prefixes here. All right, so the first one, if we have one atom, we use the prefix mono. So the prefix mono means 1. The prefix for 2 is di. The prefix for 3 is tri. The prefix for 4 is tetra. For 5, it is penta. For 6 is hexa. 7 is hepta. 8 is octa. 9 is nona or nona. I've heard it pronounced both ways. And then 10 is deca. So I would just pause the video and take a moment and try to work on remembering these prefixes here. Okay, so you've had a chance to practice the prefixes for a second. If you didn't do so already, I might jot them down just off to the side somewhere, because on the next few slides you're going to want these handy, and you probably don't have them all memorized yet. So you want them in front of you so you can refer to them if you need them. Alright, so the rules as far as actually naming the compounds is quite simple. We just name the first element followed by the second element. So very similar to the stock system for ionic naming where we name the cation, then we name the anion. We basically do the same thing here. We name the first element and the second element. But there are a few other things to consider here. The name of the first element is unchanged. So I don't change the name. For example, I don't use an IDE or an ATE ending. I just use the name of the element. The second element, I do use the IDE ending, even though it's actually not an anion, just for linguistic consistency, so it sounds nice. We do use the IDE ending for the second element. So the form of any of these compounds, the prefix showing us how many atoms of the first element will go first, followed by the first element's name. So for example, triboron would be an example. And then we show the prefix for the second element, showing how many atoms there are, and then the name of the second element with the IDE ending. So for example, we might have triboron for the first part, and then octahydride for the second part. Note the IDE ending there. And the only exception to any of this is for the first element, we do not use the mono prefix if there's one atom of it. It's understood. So we would never have mono here for the first prefix. If I just give the name of the first element, it is understood that there's just one atom there. So let's look at some examples of how these rules would apply. So we just want to name each compound. The first one we have is NO. So our rule is we're going to name the first element, followed by the second, and the second element we use the IDE ending, and then we use a prefix to indicate how many atoms there are. So notice in this case there's just one atom of each. There's no subscripts here, so I have one nitrogen atom, one oxygen atom. Now the prefix for one is mono. However, remember, we don't use the mono prefix for the first element. So the first part of this compound name will just be nitrogen. You can see that here. And then there's just one oxygen atom, so monooxide, or we would actually drop one of those O's and just say monoxide, just to make it easier to say and it sounds nicer. So nitrogen monoxide. Next one, we have S2Cl2. So again, we named the first element and the second element with the IDE ending on the second one. Remember our prefix for 2, and both of these have 2 atoms of each element, is di. So the name for this compound is disulfur dichloride. Now notice the difference between this second one and the first one is we do use a prefix here in front of the first element. The only time we don't have a prefix if there's just one, we don't use the mono there. So they're both 2 atoms, so the di prefix does appear twice here. And again, notice the IDE ending for the second element. Next example, P4O10. So here we have 4 phosphorus atoms and 10 oxygen atoms. So look at your prefixes for 4 and 10. The prefix for 4 is tetra, and the prefix for 10 is deca. So the name of this compound is tetraphosphorus decoxide. And again, notice, just for ease of tongue, if you will, it's common to drop the A. We don't say decaoxide. If there's 2 vowels next to each other, a lot of times that last vowel and the prefix just gets dropped, so it's easier to say. Alright, and I guess that was the last example for that one, naming the binary non-metal compounds. Now, like before, we also need to go the other direction. We need to be able to write the formulas of these compounds from their names. So we want to write formulas of binary non-metal compounds. So let's look at some examples here. It just says write the formula for each compound. First one we have is carbon monoxide. So consider this. We have no prefix in front of carbon. So remember, that means it's understood to be 1. So it would be 1 carbon atom. Monoxide or monooxide means there's 1 oxygen atom. So the formula here is CO for carbon monoxide. Hopefully you never get that in your house because that's very poisonous. Okay, next example, phosphorus pentachloride. Again, notice here there's no prefix in front of the phosphorus, so that means there's 1 phosphorus atom. And then penta means 5, so I have 5 chlorine atoms. So my formula here is PCl5. Next one, dinitrogen tetroxide. Di, the prefix di means 2, so we have 2 nitrogen atoms. Tetra, that prefix is for 4, so we have 4 oxygen atoms. So the formula here is N2O4. Oh, that should say N2O4. I messed that up. So please ignore my answer here. That should say N2O4 for tetra. The prefix for 5 would be penta. So if this was dinitrogen pentoxide, that would be correct. But that should say N2O4. Alright, and then we have boron trihydride. So again, there's no prefix in front of the boron, so that means there's one boron atom. And then the prefix tri means 3, so 3 hydrogen atoms. So the formula here is BH3. Alright, so that completes the learning targets here for this video. You're not done quite yet. I do have a few practice here. So like always, when you see the practice, pause the video, try it yourself, see if you can do it correctly. Alright, so some practice problems. First one here, I just ask you to write the formula for each compound. Now one thing you'll notice here on these is that I've intermixed the ionic compounds with the binary nonmetal compounds. Now that being said, if you just look at the names and follow the rules that you know that we have for writing the formulas, it really shouldn't matter. You should be able to figure them out quite easily. Alright, so the first one here we have chromium 3 sulfate. So recall what this Roman numeral 3 tells you. That gives you the charge on the chromium ion. So that's Cr3+. And then sulfate, ATE, that is a polyatomic ion. So look at your polyatomic ion chart, and you'll see that sulfate is SO4 2-. Now ask yourself, how many of each ion do you need in order for the charges to cancel or to balance? And here, that would be 2 chromium ions. So if I had 2 of these, that would get me to 6+. That would be 3 sulfate ions. If I had 3 of these, it would get me to 6-. So my formula is Cr2SO4 3. So a total of 6+ charge for my cation, a total of 6- charge for my anion. Alright, next one. We have silicon dioxide. Notice here we see a prefix, the prefix di. So this tells you here it's a binary nonmetal. In other words, you don't need to worry about the charges on the ions because there are none. There are no ions here. Just write the formula so that it matches the prefixes. So notice here there's no prefix in front of silicon, so that means there's 1 silicon atom. And the prefix di means 2, so there are 2 oxygen atoms. So the answer here is SiO2. Next one, we have potassium nitride. So here, notice we have a polyatomic ion. That tells you right away that you do have an ionic compound. So you want to identify the charges on the ions. So potassium, that's a 1+ because it's in group 1. Nitride, IDE, that's not a polyatomic ion. I just mentioned earlier, it said polyatomic ion. That's the monatomic anion of nitrogen. And so if you look at that, nitrogen is on the periodic table in group number 15, so that will be in 3-. And then, so matching up the charges here, you'll notice that we need 3 potassium ions, 3 of these over here to match the 3- on the nitride. So my formula there is K3N. Alright, lastly we have silver chromate. Silver is one of those metals, recall, that always has the same charge. It's always 1+. And then chromate, that is a polyatomic ion. I know that because it ends in ATE. And so I look at my polyatomic ion chart and I see its formula is CrO4. It has a 2- charge. And so notice I will now need 2 silvers to match the 2- charge of the chromate. So that is Ag2CrO4. Alright, last slide here. I want you to name each compound, so we're going the opposite direction here than we were before. The key here is make sure you're following the correct naming rules. You want to look at the compound and ask yourself, is it binary nonmetal? In other words, are there 2 elements? And if they're both nonmetals, then you follow the binary nonmetal rules. That's the one with the prefixes. If it's not, then follow the ionic rules, where you just name the cation and then the anion as you know how to do. Alright, first one, we have N2O5. These are both nonmetals, so it's binary nonmetal naming. And so I use my prefixes. And so that would be dinitrogen pentoxide, because I have 2 nitrogens, di for 2. Penta is the prefix for 5, and there are 5 oxygen atoms there. Next one, we have Cui2. Okay, and this one here would be ionic. I know that because copper is a metal, so it's not binary nonmetal. So I need to follow my naming rules. And again, ask yourself what the charges would be here, because copper is one of those metals that we need to indicate the charge on. Iodide is in group 17, so that's 1 minus, but there are 2 of them in the formula. So the copper has to be 2 plus. So the name of that compound is copper 2 iodide. Alright, next one here, we have a polyatomic ion, so that's a giveaway that it's an ionic compound. So just name the ions. Ca, that's calcium, and that's in group number 2, so that's always 2 plus. Phosphate is a polyatomic ion, so we can just name that. This is calcium phosphate. And then the last one we have here, XeF4, those are both nonmetals, so I use my binary nonmetal rules, so I use my prefixes. And that would be xenon tetrafluoride because there are 4 fluorine atoms. And that is the end of the lesson.